All right, here is 6-1, day 2. We will touch on computing the mean of a probability distribution again. And then we're going to throw in the standard deviation. I'll show you how to do that. And then, we'll get a visit from probability calculation that we've done before and we were actually pretty darn good at that we haven't seen in a while. Okay? Let's start with a little review of calculating a mean. Remember, it's outcome times frequency. In reality, I would probably get that 1.1 off my calculator from putting the outcomes and the probabilities in list 1 and list 2. Okay? And there we have our interpretation that if you took a lot of Fridays, that at this dealership on average they would sell about 1.1 cars per Friday. Okay? Alright, standard deviation looks like this. This is one where the calculator will be really important. It's a sum of each outcome minus the mean squared times the probability that goes with it. Okay? It is acceptable, just like with the mean, that if you wanted to abbreviate and just do the first two and then say dot, 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 you can. Okay? That's something you can do. I'm going to try, if I can, on this one to fit the whole thing in, just because I want you to see it. This is one where you should be thinking of using the calculator, because it is not, well, that says it all right there, right? It's not going to be that pleasant to write it out. But seriously, get that table entered into list 1 and list 2, and you just need to show the pattern for the first two terms, and then you'd be good to go. Okay, so this work is just to kind of show that, yeah, we get the idea of how it's done, but we're not going to number crunch it this way. So first outcome is 0 minus the mean squared times 0.3. So this is what I was talking about. If you had wanted to, you could just say dot, dot, dot underneath the square root, and then equals 0.94. Okay? Just to see more of how each part of the calculation is done, I'm just going to keep going. And here's our last one, which was 3 minus 1.1 even with the help of typing that into a calculator, that's still not that pleasant. I mean, that only had 4 outcomes. Imagine the hockey example from day 1 that had 10. Okay? The tutorial for doing the calculator part with list 1 and list 2 is on Schoology. know the calculator function. Okay? And there's the interpretation. On average, the number of cars sold on a randomly selected Friday will differ from the mean by about 0.943 cars. Now check out this one. It wants a probability calculation, and you can see the answer down below. We obviously got to fill in the work. Where's our table? No table. I'm bringing back an old friend here. Always be on the lookout for that. Okay? Always be on the lookout for that. This is a normal CDF. The distribution of weights of 3-year-old females is normal. Centered at 30.7 pounds. With a standard deviation of 3.6. We're saying 30 pounds or more. So that would be all of these outcomes over here. You can see these again, and I want you to be clear on the fact that in Chapter 2 we were calculating probabilities from a distribution. That's what we were doing. Okay? So what we're, these calculations we're making in Chapter 6 are a little bit new and a little bit different, but, kind of. Make sure to review the normal CDF feature. Okay, lower bound, upper bound, mean, standard deviation. Okay, in that order. Your calculator will probably prompt you to do that. The upper bound is the one that should be really silly big, like a billion or something like that. Now, this one doesn't give us a probability distribution, but it's not a normal CDF because you could look through that whole description. It doesn't say anything about it being normal, but it's because we're going to make our table. Pretty basic one though. It only has 3 outcomes. Okay, only 3. This kind of like a fair or a carnival game where you win tickets to exchange them for prizes. Our game offers the chance to win more tickets. You throw a dart at a balloon, it pops, it tells you something. One of 3 things. Hey, you won 5 tickets. Hey, you won 3. Or, sorry, you didn't win any. Okay, so those are our 3 outcomes. And the paragraph tells us we have set up the game so that we will give out the prize of 5 tickets 12% of the time. Three, 20% of the time. 0, 68% of the time. If I wanted a mean, right? Remember what the mean, it's the sum of your outcome times the probability that goes with it. You should always think of these, in the table, like the outcome and the probability, they're like a package deal. They're a pair, and through these calculations, they stick together. Because that's really important that, we made the outcome of winning 3 tickets, but it happens 20% of the time. Okay, so that 0.2 and the 3 have got to stay together. So on average, we are going to be giving out 1.2 tickets. Think of law of large numbers. As this game is played and played and played per game, we're giving out 1.2 tickets. Now, that number is super important because if you're running this game, you better charge. Unless you basically want to be a charity to just give out tickets, you need to charge at least 2. Right? Because if you charge 1, you're taking a net loss, and you're going to be giving out more tickets than you're taking in. Okay? Someone at the fair figures that out. They just say, hey, yeah, I'll lose the game, but long term, I just got to keep playing, because if I play this game a ton, I'm walking away with more tickets than I started with. Unless we charge them too, and then they're going to be looking at a net loss. They may win, like if they play once, they may win, but they wouldn't be in a situation where they know they're going to take a long-term gain if they keep playing. So we'd have to charge at least 2. This is the last thing for today. I know you've already seen it, but it's worth seeing again. Again, I'll give you the whole calculation. Each piece of data minus the mean squared times the probability. I'll write them all out because there's just 3 of them. But again, if you like really had wanted, you could just write out 2 of them. But that, like if this were a test question, that wouldn't be that common. You would pretty likely just write out all 3. Though you should still go to list 1 and list 2 to get the answer. There's 5. Here's 3 minus 1.2 squared. Plus, all right, got to try to fit this last one in. 0 minus and I got it. 0 minus 1.2 squared times 0.68. The square root of all that, about 1.83. Okay? Which on average, that's how much variability we would have from the mean.